Frequency polygons are a graphical device for communicating the shapes of distributions. They serve the same purpose as histograms, but are especially helpful in comparing distributions. Frequency polygons are also a good choice for displaying cumulative frequency distributions. To create a frequency polygon, start just as for histograms by choosing a class interval. Then, draw an x-axis representing the values of the scores in your data. As an example, we are going to create a frequency distribution for the scores on a psychology test. This is the same data set from the histogram section. We choose a class interval of 10. Our first interval extends from 29.5 to 39.5 and has a midpoint of 35. Note that this interval does not contain any test scores. Neither does the highest interval, which extends from 169.5 to 179.5. We choose first and last intervals that do not contain any test scores, so the line will touch the x-axis. Draw the y-axis to indicate the frequency of each class. Next, we are going to use the data from the frequency table to place a point in the middle of each class interval at the height corresponding to its class frequency. The graph does not show the upper or lower limits of the intervals. Finally, connect the points. Note that there is one class interval below the lowest value in your data and one above the highest value. As a result, the graph touches the x-axis on both sides. You can easily see the shape of the distribution from this figure. Most of the scores are between 65 and 115. It is clear that the distribution is not symmetric, inasmuch as good scores to the right trail off more gradually than the poor scores to the left. That is, the tail is longer to the right than it is to the left. This kind of distribution is called a distribution with a positive skew. It is also called skewed to the right. A cumulative frequency distribution shows the cumulative frequency for each class interval. The first interval has frequency and cumulative frequency of 0. The frequency of the second interval is 3. The cumulative frequency is the sum of the frequencies of all intervals up to and including the one in question. The third interval has a frequency of 10. Its cumulative frequency is 0 plus 3 plus 10, which equals 13. A cumulative frequency polygon for the same test scores is shown here. The graph is the same as for a frequency polygon, except that the y value for each point is the cumulative frequency rather than the frequency. For example, there are no scores in the interval labeled 35, 3 in the interval 45, and 10 in the interval 55. Therefore, the cumulative frequency for 55 is 0 plus 3 plus 10 equals 13. Since 642 students took the test, the cumulative frequency for the last interval is 642. Frequency polygons are especially useful for comparing distributions. This is achieved by overlaying the frequency polygons drawn for different data sets. This figure provides an example. The data from a task in which the goal is to move a computer cursor to a target on the screen as fast as possible. On 20 of the trials, the target was a small rectangle. On the other 20, the target was a large rectangle. Time to reach the target was recorded on each trial. The two distributions, one for each target, are plotted together. The figure shows that although there is some overlap in times, it generally took longer to move the cursor to the small target than to the large one. It is also informative to plot two cumulative frequency distributions in the same graph. This is illustrated here using the same data from the movement task. The difference in distributions for the two targets is again clearly evident.